So for our next example, we're going to look at a chemical reaction when benzene reacts with bromine. Bromobenzene is obtained, as well as hydrobromic acid, okay? So our first step before we do anything else is to verify that this equation is balanced. So we'll just take a peek at this. There are 6 carbons on both sides. There are 6 hydrogens on both sides. So far, so good. And there are 2 bromines. And so this chemical equation is already balanced. So in part A, we want to know when 30 grams of benzene reacts with 65 grams of bromine, what is the theoretical yield of bromobenzene? So you'll notice that there are 2 masses here. So this is a limiting reactant question. And so we'd like to know whether the benzene or the bromobenzene is controlling the amount of bromobenzene produced. So to do that, we will determine for both the benzene and the bromine what the quantity of the other would be that's used. So for 30 grams of benzene, how many grams of bromine should be utilized? So we're going to convert grams to moles. There are 78.12 grams in 1 mole of benzene. Now we're going to convert from moles of benzene to moles of bromine using our stoichiometric ratio, which in this case is 1:1. Now we want to convert from moles of bromine to grams of bromine. So don't forget that Br2 means that there are 2 components here, and so you need to double the atomic mass, which is 159.8 grams of bromine. So now we need 61.36 grams of bromine. Okay, so you'll note that it says that we have a total of 65, which tells us that benzene is the limiting reactant. Now, I'm going to go ahead and calculate the alternate method, but this would tell you which is the limiting reactant, okay? So for 65 grams of bromine, how many grams of benzene would you need? So there are 159.8 grams of bromine in 1 mole of bromine. Using our stoichiometric ratios, which are still 1, for every 1 mole of bromine, 1 mole of benzene is used. Now we'll convert to grams of benzene and 1 mole of benzene. There are 78.12 grams of benzene. When we plug this into our calculator, it says that we need 33.77 grams of benzene. So you'll notice that we have less than we would need to consume all of this. And so in this case, benzene is the limiting reactant. And so we need to use the quantity of benzene in order to determine the amount of bromobenzene, okay? So for the 30 grams of benzene, now we're going to convert this to bromobenzene, okay? So we're going to do it just the same way we've already done it. There are still 78.12 grams in 1 mole of benzene. In this case, we are going to convert to bromobenzene, which is a 1:1 ratio. So for every 1 mole of benzene, 1 mole of bromobenzene will be created. Now we can convert this to grams. So in 1 mole of bromobenzene, which weighs 157.10 grams, there are 60.3 grams of bromobenzene produced, 6H5Br, okay? This qualifies as a correct answer because it still follows our significant figures, so it answers the theoretical yield. If this reaction goes perfectly, this is how much product you would expect. Oftentimes, it doesn't go exactly correctly, and so we get an actual yield of 42.3 grams. And so what is the percent yield? So to calculate percent yield, it is actual yield divided by the theoretical yield times 100. And so in this case, we have 42.3 grams divided by 60.3 grams. We're going to multiply by 100, and we get a 70.1% yield.